alternative series remainder, and it's kind of confusing. So you can use your calculator to kind of reinforce you. So, Derek, I cannot talk over you. This is a very hard lesson. This is one lesson I failed to teach last year. So I want to redeem myself. Hopefully, do a better job at explaining. Yeah. So last year, student didn't really understand. I think only like 2 students got it right after the test. I wanted more than that. So please don't mess up here. But today I will try to teach you like as much as I can, and make sure you understand it. So,
This year because everything's easy. So if he's saying this is hard,
If he's saying it's confusing, we're basically screwed.
yeah. No, he'll get it.
I'll get it, but then I'll still mess it up on the test anyway.
If you'll explain it to me using your own words, then I'll get it, and I'll have to study it to remember, and then.
all right. So what we're gonna do is we're gonna talk about what is the error, and how do you find the error. And here's the margin of error for array plus minus something, and that So those of you guys don't know your plus minus. Do you guys know plus minus, right? That your weight is 150 pounds, plus minus 1, depending on if you go to the bathroom or not, right? So, yeah, that's why I say in third period everybody got offended.
From what?
Depending if you shit or not.
It's true though.
Yeah. So you have some plus minus, right? All right, Derek. Shh. Right. Next thing you have to understand is what is the error. So you have to make sure it's alternative series remainder. So alternating series remainder. This is the last part of the test, and this is probably, it's actually not hard, but I'm really crappy at explaining this. Okay, so first of all, let's give you some ideas. They say if summation of a to the n is converged. So usually this is alternative series is converged. Then it will have sum s.
Wait, like it will have like some of the s, or like
No,
like
Sum.
S-U-N.
Summation.
S-U-N.
Oh,
Sum.
Not S-O-N-E.
okay.
Then the limits of the partial sum if, let's say, limit n approach infinity, that is gonna equal to s. Why? Because this is what they created. So if, let's just say, if I go to infinity of the Sn, that's equal to the sum. The whole sum.
Wholesome.
The whole sum, yes. So,
Um,
okay, so far, hopefully you don't get confused, is if n approach infinity. But
wouldn't it be if it approaches an n value other than 0? Isn't the sum like infinity?
no, I mean sometimes series converge. You're not gonna go. You're gonna go to infinite, but it's gonna be finite. But this finite value, if it ends approach infinity, that's gonna be equal to the whole sum. But the problem is not all the time we can reach infinity, because that require, even your calculator doesn't have an infinity button. That's why in stats you do 9999999 when you do like normal distributions.
We have an infinity button, so it just works out.
You do?
Yes.
Yeah, there's an infinity button.
I always type in
You know,
I always
this will-
teach
Like
99999.
this gives you a list of
Constants
constants.
and like infinity in the
Yeah,
degrees.
he does teach that, but sometimes you get like values that you have to deal with, like 100,000, and then you might not do.
Oh, we have infinity too. Oh wait, no, I know.
It is. You hit pi, and then the pi button on the bottom left for the end spire.
Okay,
And you just keep collecting it until you hit 70.
No, I
so that result with n approach infinity of s minus Sn is equal to 0. Why is it equal to 0? If they reach infinity, the comparison between the whole sum and the partial sum go to infinity, they subtract each other, are going to 0. Now,
Is that the same thing?
yeah, they will become the same thing if they reach infinity. But the thing is, you don't always reach infinity, so we need to consider the case that doesn't reach infinity. So,
Oh god.
But the limit approaches infinity.
yeah, if it reach infinity, it's going to be a whole sum. So they subtract each other, should get 0.
Yeah.
That's it. That's the only thing that statement says. Now, so if n does not reach infinity, so n does not,
What are you quoting?
reach,
Put it
I quoted n,
Okay.
Off center.
Okay.
does not reach infinity, does not reach infinity, we're going to just write that word, there will be some error
Oh, this is the other sum now.
between S and then Sn. There's some error. And we're going to call it error r to the n, which is remainder. So if it doesn't reach infinity, the difference should be 0. If it doesn't equal to infinity, we're going to call it Rn. So this is Rn?
Like a horizontal asymptote or something? I meant a vertical asymptote?
No.
Just think literally n like limits and
Like it doesn't approach infinity?
limit as n approaches 1,000.
It didn't make it all the way. Got tired.
Yes, it got tired. Let's just say, don't even think 1,000. Like Robert says 1,000, you just go into the 5th term, which is most of our calculation is going to be between 5th term and 6th term. So let's just go to 5th term. If we go to 5th term, the whole sum minus the partial sum is going to call the remainder. Okay, so this error, we call it R, is equal to the whole sum minus the partial sum. Are we okay here? Okay.
Really fun.
I
I
know.
like
Like,
that so much.
I love drawing. Right.
I'd rather do long division with polynomials than this.
Not really.
Okay, so your mind need to stop thinking that. The thing is, your mindset is wrong. Your mindset is gonna be like, okay, I can do anything you
So
ask
those are,
me to
like,
do.
different remainders?
No, I'm gonna ask you. Says your mindset need to switch. Your mindset need to says I can do anything better than you can. Not this is too hard for me.
No, I'm gonna figure it out eventually.
Yeah, I know.
Yeah, he's-
But you say this is harder than long division. It's not. It's actually a lot easier than long division. But
easier than long division?
it is a lot easier than long division. But it was. I'm not experienced to explaining this, so I'm trying. But you have to keep the right mindset. That's what I'm trying to say.
Is that S?
So we're gonna say S equal to this is a whole sum. The whole sum is gonna be A1 minus A2 plus A3 dot keep on going until minus A to the n.
Bless you. Wait.
Now there was a different color here showing up. There is also the next term, an plus 1
What, are the signs changing?
minus an plus 2. It just keep on going. Just let me finish. It's okay. And then they will keep on going, right? They will keep on going. But this whole thing, we're going to call this the whole sum. But right before the Sn, here we're going to call it the partial sum. So this is Sn. It's a partial sum.
Yeah, that makes sense because it's a part of the.
Now, what is this part? This part is what we're interested today. is the remainder.
I get it. Good job, Andrew.
But you pay attention, it stopped right here, right? It stopped right here. So the rest of them, so the things that we want to pay attention is a to the n plus 1.
Is this recursive?
No.
No. Yeah.
Okay, so that result with s minus Sn equal to Rn, and then that result with s minus Sn also less than a to the n plus 1. Now this part is the crucial thing of what happened, because all this part add together, it's going to be less than this term.
That's fine. Okay, the first equation is.
Wait, can you repeat that part?
Imagine that, just say imagine this, right? Imagine that if you have the harmonic series, 1 minus half minus 1 plus 1/3 minus 1/2 1/4, right? Plus 1/5 minus 1/6 plus 1/7 minus 1/8 plus 1/9. You get the point, right? Da, 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 da.
Is this oh, it's all these. What did you explain that?
If that's the case, right? Let's say we stop right here. Let's say we stop right here. Boom, we stop. We stop at a 6th term, s to the 6, right? So whatever this add up infinity is always gonna add less than this. Because this, if you keep on adding, it's just gonna get smaller and smaller and smaller. Do you see what I'm saying? Because you adding, subtracting, adding, subtracting, but never outrun this number. Never ever outrun this a to the
So
n
it's
plus
saying the
1.
remainder is never.
Never surpass 1 over 7.
Yeah.
Never surpass 1 over 7. Whatever this number keep on adding, which is the remainder, never pass this term. This term is going to be, because
that's
after
what-
that it's going to be subtracting and adding, subtracting and adding. Remember that the thing that we're going back and keep on going back. This thing here, 1/7 is always going to be greater than all the infinite term adding together, because you're adding, subtracting, adding, subtracting. It's going to be smaller than 1 over 7. Got it?
What if you stopped at 1 over 7?
We stop at 1 over 7, then 1/8 is going to be bigger than all the things together here. So yes, and then you come to mention that absolute value, because that remainder could have been absolute value. So this is the alternative series. S minus Sn is equal to R to the n, but is less than a to the n plus 1. Always less than a/n plus 1. The remainder is always less than the next term. So even you combine all those things together after this, you'll never outrun 1 over 7. It's always going to be smaller. Does that make sense? Okay, so that's basically it. We're going to try a problem. This problem we're going to try is the summation of n equal to 1, infinity, -1 to the n plus 1 times 1 over n factorial. And we know is 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial and dot, 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 and keep on going. So at first, I will see if this is converged or not, because if it's not converged, this does not work. So how do you know it's converged? Well, A is check, right? Alternative. Got it? That's very easy to check. Is limit of n approach infinity of 1 over n factorial, is that equal to 0? check. So, and the last thing to check, are they decreasing? Well, we're gonna compare n plus 1. Is that less than 1 over n factorial, which is true. And check. So it converge.
Well, what was the last one?
Decreasing.
Okay.
Yeah, why did you do that?
I just compare the
Well,
next
you can't
term.
do- You can't do the derivative to prove it. Like you can't do the derivative of factorial, but the other way to do it is a of n plus 1 has to be less than
Oh,
a of n.
right.
It's just same thing, a same concept as 1 over n compared to 1 over n
Yeah.
plus 1. Except this time it's a factorial. So so it's same idea. So we know that's converge. And then we say, hey, can you find the sum of the series by its first term? First 6 term.
Does it always have to be 6?
No, and just in this case it's 6, but in your calculator it can be easy to do. So you should know how to use your calculator. You can do S6. It looks like this, but you should be able to do a calculator. Just plug in the equations, and then you should get a fraction.
Okay, so when it asks you to find the sum of the series,
Then I just added up manually.
Yeah, it'll always tell you how many terms it wants you to do.
They will tell you yes.
Will we always have our calculator for this type of problem?
Yes, this problem you will have a calculator.
So we have calculator.
No, only on this problem. Well, yes,
Why was
only on
the
this problem.
Series
By its
6 term.
How do I do
First
Less than 6.
math.
Okay, math.
Do we say like
Summation.
x equals 6?
Yeah.
Calculus.
No, you gotta put 6 on the top. X is where you start.
Oh.
We're gonna start 1, 2, 6.
That is so true.
Usually we go from 1 to infinity. Which is why there's an infinity.
That makes sense.
Did you guys not know how to sum menu?
Yeah, Drew, what did you do?
No, I did. I completely forgot. It's always infinity on top.
I need to.
I don't want to do it, which is why I'll be happy.
Okay, so we do alternating series, so we plug in the a of n on the top.
It would be 1 over n factorial. But also it's negative 1 to the n
Yeah.
plus 1.
So you can use a calculator. Page, I think you use TI Inspire.
We wrote the function.
The button is gonna be the button. Which one is a button on TI Inspire? Xavier.
Menu.
4, 5.
Huh?
Menu. Calculus.
Menu 5.
Menu 4, 5.
Menu 4 5. So for Page that who's not here, that's the only person I know is not here. What, Trevor's here? Okay, I can never tell Trevor's here or not. So quiet. So for Page is a menu
Let me find a factorial.
4 and 5 or 5 and 4.
4 or 5.
4 or 5. Okay, 4 and then 5. Then you could go to the summation, and hopefully you come up with a number here.
Hey, Will, where's the factorial button?
Where's factorial?
I don't know what's factorial button.
Do you know how to find factorial?
Oh, hold on. Okay, so you do menu, and then the what looks like a book. It's next to the one you use for derivatives, and it'll be index of all the different functions. Yeah. Okay, so it's control, then whatever is like you see the book. It's right below the delete button.
Oh, I found it.
Where's factorial?
You know what Inspire, right?
Yeah.
Control,
Control.
and then you see the menu button below the delete button.
So factorial button.
That,
Okay.
it should be around like maybe 2 to the right.
Select variable. Symbols.
Yeah, yeah. Oh, there's a bunch of symbols.
You gotta find the page. Sorry, I don't know what's that.
Do I just go down?
What are you talking about?
I'm talking to Paige that if she's listening to this video.
Tell her that to find the.
I did it.
You come here. You tell her. You can show her too. She used Inspire.
We got. You guys get 91.
Control, menu, top box, symbols, scroll.
Enter.
Just write control and then the book.
Okay.
Give you the.
This factorial is control
No, you're supposed to put like the summation
in the book
Yeah.
on the right, right
Yeah, it's right under the delete button.
under delete.
Yeah. Oh, he didn't hear it?
You should get 91 over 144, right?
Yes. What are you guys having trouble with?
No, I got it.
No,
Accidentally calculated the sum and going to infinity. Just say.
how do you even have that up there? This typing is way more difficult than Did you just type all that?
No.
Typing's way more. No. Yeah, you had to.
I use the bottom.
Why is
Yeah,
I know.
keyboard on the calculator.
That's part of the type.
Instead of 40.
Oh, okay. You're there. You're at
Control.
Control.
No.
Okay.
No.
No, it's game.
Yeah, you guys said
That will work for me.
This is right then.
I just inspire stats.
So Paige, you're probably gonna ask me questions as what the question is. Here's a find the sum of the series by its first 6 term. And if you use calculator, you should get up to this, and you should get 0.63194. Now, however, now you gotta think about it. What will be the error? You know, you got a plus minus. So if you go to bathroom in the morning, you're gonna lose a pound. If you eat a hamburger, it's gonna gain a pound. So you need to find out what the error is.
It would be the sum from 6 to infinity, right?
6 to infinity, but it'll be easier to find out just the next term, the 7th term.
Oh yeah.
So because s minus, so this is a crucial part. I'm gonna use a different color. So it'll be s minus s to the 6. This is the remainder of the first after the 6th term, but it's less than a to the 7th. It's less than a to the 7th. So all you gotta do is figure out what the a to the 7 is. A to the 7 is which is 1 over 7 factorial, which is equal to 1 over 5040, which is roughly equal to 0.002. Yeah, 30. Now, this is the absolute value of it. Because this is absolute value, you're going to say, what about the negative sign? Don't worry about the negative sign.
Okay.
This is the error. So what your sum will end up to be is 0.63194.
Plus or minus.
And it could be
Where do you get
plus 0.02. So plus
Yeah.
Oh.
0.002 and 0.63194 minus 0.0002. So the number,
Can you
the
just plus or
sum,
minus?
huh?
Can
Can
you
you
just
just
plus or-
write plus or minus?
But I want to tell you the sum is between those two numbers. The sum is between those two numbers. So I cannot do, you can think about it as plus minus, but just between those two numbers. Is that okay?
Okay.
She always go to the bathroom and on the most critical time. You can go bathroom beforehand.
I tried to go before class. There's a line.
I guess I cannot explain
Yeah.
girls' bathroom.
The only line in the guys' bathroom is people who are just smoking.
Yeah. You can just walk.
Yeah, you just walk past them.
Just join them there.
No. It's disgusting.
You gotta say smoking bad.
Okay, shh.
They go to
So in this part, the error is gonna be tell you the marginal error of the sum is going to be. It's gonna be between those two values. It's gonna be between those two values. So what's nice thing is you can say, well, it's plus 0.002 or minus 0.002. It's gonna be in between those. Now I'm gonna show you the next question. The next type of question is say, well, hey, can you determine the number, right? The number of
Is this a new
term.
lesson?
No, this same type of question. Require 1 over 7 factorial.
That was the
Because-
a over n plus 1 term. A to the a sub n plus 1.
Yeah, because-
That was that term.
Your next term is gonna be the 7th term. All the error that it's gonna be for the first 6 term error, for the rest of the things combined, is always gonna be less than a to the 7. So what I'm gonna do is I'm gonna go figure out what a to the 7. This is my error.
Oh, okay.
That's my marginal error. This is actually really easy. This is like easiest part. It's easier than long division. Because all you gotta do is plug in the 6th term, but you want the 7th term. So just plug in 7 and 7 factorial using the absolute value. Is that okay? Okay, now what if next time the question is different? Determine the number of terms required to approximate the sum of the series.
Do you have another one of those books?
Hmm?
That textbook.
You can take a picture of it if you want.
Love
Yeah. But I'm gonna explain to you so what happened you actually know what's going on.
We're calculating confidence intervals.
Okay. With an error less than 0.001. So this is the part that's going to be less than 0.001. Now, what equation I'm talking about? N equal to 1, infinity, -1 to the n plus 1 over n to the 4th. Now, if you want an error is less than 0.001, what do you compare?
You find a term that's less than.
You find a term that's next term.
Yeah, the next term.
Okay, so what is the next term of this?
Infinity plus 1
No. What is the next term of this one?
plus 1.
1 over 1? What are you talking about?
Plug in n plus 1 for n.
And we do absolute value of it.
Oh, hold on. Let me get my calculator out.
Wait, what are we plugging in?
We're trying to find we're trying to find a term that has 0.001, but it's like the next term.
Yeah, but right now we're not trying to overthink it. We're just gonna take this, right? And we're gonna say next term. What is the next term is of this?
1.
N plus 1.
M plus 1 factorial.
So many. Yeah, he did say that a lot.
Okay, I'm sorry, I didn't pay attention.
Like.
Andrew.
And it's less than 0.001. Does that make sense? If it's less than 0.001, you got a job done.
Please release your students for
Okay, guys.
Hold on. Let me finish this part. This part is actually very easy. I'm going to do this 0.001 times n plus 1 to the 4th. And I'm going to divide it over. So it's going to be 1,000 is less than n plus 1/4. Now all we got to do is plug in number until they are greater than 1,000. So imagine n equal to 4, so it'll be 4 plus 1 to the 4th power. That's 625. If you got 5 plus 1 to the 4th,
It's get and check after?
no, you can actually evaluate. If you evaluate, it's going to be 4.6. But if you don't have a calculator, you can try it because the number is not too hard. You divide by both sides by 0.001, you get 1,000. And then you will get, eventually, this is going to be greater than 1,000. So the n is going to be 5. So n is 5. That's the, if you got a fifth term, we'll have less error than 0.01. Okay, you will find out the error that has less than 0.01.
Even 100, it's definitely less.
Didn't we also?
Your homework is a whole packet, but you got 3 days to come. You got what? Today, tomorrow, and
Series.
I can send it to you if you want. You want me to send it to you?
Oh, the function is changed.
Not yet, but I can send it to you right now. I don't see your phone. You don't have to finish everything. You just try as much as you can. Do the one you can, and do the one you can tomorrow in class. So you pretty much have 3 days.
On Amazon Prime. Watch it. It's a great show too. On the A-Train TikTok. Valentine's Day. Okay, wait, Like the very start, the very first episode.